Hi, physics. Mr. Janowski here. This is the third part of the chapter 3 slides, and this should be a very short little video here because there's only 2 slides to get through, and we're just reviewing things. So, if we're looking at this, what do the horizontal white lines in the first picture, the picture on the left, tell us about the motion of the two balls? So, notice the horizontal white lines, which indicate the vertical position of the two balls. Um, Two things to notice. They're getting more and more spaced out as the balls go down. That's because the balls are accelerating downwards. And the other thing is, it's the same white line for both the red and the yellow balls. So if we're looking at this over here, the fact that it's the same lines means that both of the balls are falling downwards in the same way. And the fact that the yellow ball is going sideways is not affecting the way that it is falling downwards. And the flip of that is kind of true with the picture on the right. So in the picture on the right, there are these vertical lines which indicate the horizontal position of the yellow ball. And what do we notice about these? We notice that the spacing is very even. So that means the yellow ball is moving to the right at a constant rate. And the fact that it is going down and even accelerating down as it's doing that is not affecting the way that it's going sideways. So in the first picture, the fact that the yellow ball is going to the right is not affecting the way that it's going down. And in the second picture, the fact that the yellow ball is going down is not affecting the way that it is going to the right. So this is the idea of things being independent. Um, the vertical motion, y direction motion, up and down, is perpendicular to the left-right motion, the horizontal motion of the ball. So these things are independent. That means they stay out of each other's way, and that is what lets us do the problems that we do. So what are the steps of the 1D kinematics problem? What are the steps of the 1D kinematics problem? That's weird. That's not stated correctly. Anyhow, remember there are 7 steps in the one-dimensional kinematics problem solving strategy. Step think about what you're solving for and what units you expect it to have. Sketch. Variable bank. There will be 6 variables in a one-dimensional kinematics problem. Step 3, which is basically just do step again. What am I solving for? Step 4, pick an equation. Remember, there's 2 conditions for picking an equation. Step 5 is do the math. And the 7th step of the 5-step process is step which means think about your answer. Does it match your step Did you solve for the right thing? Did you give it the right units? And is it a realistic number? So when we're doing the 2D problems, what are the steps? It's a little longer. There is a new step. We now have step 0. We have to find the components. Step 2, the variable bank is longer. Now there are 12 variables, really 11, but say 12. It works. But other than that, it's kind of the same thing that we did last chapter, and most people did very well in the last chapter. Step 2, step 3, step 4 on the y side, step 5 on the y side, then do a little step and then you do step 4 on the x side and step 5 on the x side, and then you do a step So remember, as we're doing these problems, yes, these problems are harder than last chapter, and they're longer. So yeah, it is harder. But not that much of it is new, really. You're kind of just integrating a couple of new things into what you already knew how to do. So that's the way it works. It's not so very, very bad. So after this in class, after we covered, just these 2 slides, we went and we did problem 7 from homework 2 as a we do. And I've got a video on that. So I'll put the link to that video in the description to this video. So hopefully you found this helpful.